Hi everyone, welcome once again, Harish, next slide, to our webinar on IEC 62443. Join with me today, I have Harish Kishore from ABB, and Harish is Hub Asia's Regional ICS OT Cybersecurity Manager. He's also IEC 62443 certified with leaps and bounds of experience in OT security. We also have Malcolm Bailey, APAC Professional Services Senior Manager from Nozomi Networks with more than 29 years of experience under his belt. So jumping into the next slide, today's agenda will be talking about the 62443 essentials, ISO 2701 versus 62443, as well as a use case and how compliance plays into your business's overarching strategy, and there will be a Q&A at the end. So for any questions for Q&A along the way, just place them into the chat box. We'll answer them at the end of the section. And with that, gentlemen, take it away on IEC 62443 and its significance.
Hey, thanks, Valerie. Good morning, good afternoon, everyone. I'm Harish. Quite excited to be a part of this ABB Nozomi webinar on 62443. Quite a huge turnout today, and I think Malcolm and myself are quite excited to be a part of this. So let's dive right into what makes 62443 the OT benchmark standard in the ecosystem today, right? We see that 62443 has been spoken about a lot, and it looks a bit cumbersome to start with. But this webinar is mostly going to guide you on how to get started with it, how to go about when you're getting started with it, and what are the pitfalls or common challenges you could face, right? So one of the most important or common things about the 62443 is how seamlessly it brings a common terminology and model into the whole ecosystem, right? Engineers, operations, and maintenance, focal plant management, cybersecurity professionals are all talking the same OT security language with 62443, right? The next part is where we also have the security being driven across the full life cycle by 62443, right from design, integration, operations, maintenance, and with until the decom. We see that there is a long-term resilience being prioritized instead of project-based security, right? So one of the most crucial elements of the 62443 is the 2-1, which defines how organizations can set up governance, policies, and processes. It treats OT cybersecurity as a management program, right? It is no longer just a project-based requirement. It is more about a holistic program you drive, similar to how we look at process safety or quality in our OT ecosystem. So the next important or crucial element which we are going to talk a lot about today is the 3-2 and 3-3, where we look at how the risk-based approach becomes a crucial part of the OT security maturity. 3-2 focuses more on assigning target security levels to your ecosystem. This also brings in the element of how you could architect a defense in depth approach on your OT system under consideration. We have a small use case towards the end where we are going to talk more about that. Prioritizing secure by design is where vendors and suppliers or OEMs like ABB have a major part to play. We are not left out of the whole ecosystem in 62443. 4-1 and 4-2 kind of ensure that we are on the same plane when it comes to this, right? The last part about why 62443 is crucial is one of my very favorite ones, where how the whole OT ecosystem around asset owners, the service providers and product suppliers are all brought on one plane. Asset owners today govern, prioritize operationalization, service providers integrate securely, and suppliers like ABB deliver secure by design products, right? So this creates a very nice ecosystem of shared responsibility, bringing the whole OT ecosystem onto one page. So that makes 62443 more crucial and relevant. Over to you, Malcolm, to talk about how it links and applies to the SOKI today.
Beautiful. Okay. The next slide. Yeah, thank you. Yeah, welcome everyone. Excited to be here. So I'm just going to talk to you about how 62443 links to and helps you comply with SOKI. So today we'll unpack what IEC 62443 actually requires for OT environments, the status of the standard in Australia, and most practically how to use it to satisfy the SOKI Act obligations. For global context, SOKI is a framework for managing critical infrastructure security in Australia. It is designed to uplift Australia's critical infrastructure protection and places requirements on responsible entities across 11 critical sectors. In July 2025, Standards Australia adopted IEC 62443 as a national standard. That makes 62443 the reference OT cyber standard across sectors like energy, water, transport, healthcare, and building automation. Because 62443 is now a national standard, it is the backbone of your critical infrastructure risk management program. It gives you a defensible, sector-accepted way to meet the cyber and information security limb of SOKI. So by demonstrating good practice to the regulator and to streamline procurement and vendor assurance across OT-related projects. SOKI asks for a documented board overseen risk program that identifies material hazards, minimises or mitigates risks so far as reasonably practicable, stays current and is annually reported. 62443 gives you the OT-specific operating system for that program. Part 2-1 for the asset owner OT security program, policies, roles, risks, KPIs, and continuous improvement. Part 3-2 for a risk assessment and target security levels and the zones and conduits designed to contain impact. And Part 3-3 for the control catalogue to meet the risk-driven targets. SOKI requires reporting within 12 and 72 hours depending on severity. Parts 2-1 and 3-3 embed detection and time response to events. So you can detect, triage, and evidence incidents fast enough to meet SOKI timelines and separate OT versus IT impacts, but accurate reporting submissions. The systems of national significance are a very small subset of critical infrastructure assets that are most crucial to Australia and have the potential for cascading consequences to other critical infrastructure assets as sectors if disrupted. The enhanced cybersecurity obligations can be applied to systems of national significance as declared by the Australian Minister for Home Affairs as part of SOKI. The obligations include developing cybersecurity incident response plans to prepare for a cybersecurity incident, undertaking cybersecurity exercises to build cyber preparedness, undertaking vulnerability assessments to identify vulnerabilities for remediation, and providing system information to develop and maintain near real-time threat picture. So using 62443 parts 3-2, 3-3, and 4-2 as your control assurance baseline produces the exact artifacts that is expected for enhanced cybersecurity obligations in the way of network zone diagrams, SBOMs, hardening baselines, vulnerability reports, and test evidence. Next slide, please, Harish.
Yep.
So responsible entities of the asset classes listed in the SOKI Act application rules are required to establish, maintain, and comply with a written risk management program that manages the material risk of a hazard occurring, which could have relevant impact on their critical infrastructure asset. The CRIMP hazard rules contain obligations related to protections within 4 key hazard vectors. SOKI asks for process to minimise the likelihood of cyber incidents and mitigate their impact with clear identification of critical components. 62443 provides the technical and procedural controls under those 7 FRs. For example, strong authentication, allow listing, secure remote access, network segmentation, monitoring, backup, restore, and time-bound response. You can set security levels per zone and select 62443 Part 3-3 controls to meet them. SOKI also asks for supply chain risk management in your CRIMP for suppliers, logistics, and services. 62443 addresses this via Part 2-4 as requirements for service providers and integrators. Parts 4-1 and 4-2 for secure product development and component security. So add those requirements into your procurement contracts, FAT, SAT, and acceptance criteria. Also, SOKI includes personnel security in scope as the trusted insider risk posed by critical workers who have the access and the ability to disrupt the functioning of the asset. And Part 2-1 requires role-based access, training awareness, and management inside a third-party access for control systems, which directly supports the personnel requirement of CRIMP. SOKI also includes the physical natural hazards in the CRIMP. Now, 62443 is cyber-focused, but its zones and conduits and the critical component identification help limit incidents and plan resilient architecture that pairs with those physical controls. So by adopting 62443, organisations not only demonstrate compliance, but also implement a globally recognised best practice for OT cybersecurity, reducing regulatory risk and improving operational resilience. Next slide, please. Okay. So this slide presents a side-by-side comparison of two cybersecurity standards, ISO 27001 and IEC 62443. So while both aim to enhance security, they serve different domains and have distinct approaches. Understanding these differences is crucial for selecting the right framework depending on your environment, whether it's IT or OT. ISO 27001 is designed for IT systems and focuses on the CIA triad, confidentiality, integrity, and availability. It's widely adopted across industries for managing information security. Whereas IEC 6243, on the other hand, is tailored for operational technology and industrial automation control systems. It flips the CIA model to prioritize safety and in aid of availability, integrity, and confidentiality, reflect those unique needs of the industrial environments. The approach for ISO 27001 follows a process-oriented and risk-based approach through an information security management system known as the ISMS. This involves setting policies, establishing governance structures, conducting audits, and pursuing certification. 62443 takes a lifecycle-oriented security by design approach. It covers everything from OT security programs like 62443 2-1 to system architecture in 3-2 and 4-2 for component development. The typical stakeholders include IT managers, CISOs, and compliance or audit teams. These roles are responsible for implementing and maintaining the ISMS, whereas stakeholders in OT are more diverse. Now, we have the CISOs, OT asset owners, plant personnel, system integrators, and OEMs. Each plays a role in securing the industrial operations. Organizations can be certified against ISO 27001. That demonstrates their commitment to managing information security effectively. Whereas 62443 offers certification for components, systems, and processes. This ensures that security is embedded throughout the life cycle of the industrial solution. So where to use? Now, ISO 27001 is best suited for enterprise-wide IT security governance, especially in environments where data protection and regulatory compliance are critical. Use 62443 in OT environments where uptime, safety, and resilience are paramount, such as manufacturing plants, utilities, and critical infrastructure. As an example, ISO 27001 requires the security control to be implemented for a clear desk and a clear screen. Considering this scenario for OT can create an unsafe condition for auto-locking an operator engineering workstation, thus preventing him from the ability to send a control command or monitor a critical asset. 62443 does not include any specific requirement to an ISMS, but it requires the establishment of security management as part of the security program of the asset owner. If an organization has an established ISMS based on ISO 27001, the security program in the OT environment should be coordinated with that. So I suppose in summary, ISO 27001 is ideal for IT-centric environments with a focus on governance and risk management, while IEC 62443 is purpose-built for securing industrial systems with a lifecycle and design-based approach. But choosing the right standard depends on your operational context and security priorities. Thank you. And over to you, Valerie.
Hey, Malcolm, if I can add a point in here, I think you laid out the distinction or the uniqueness of 27001 and 62443 and how they could complement each other, right? One interesting fact is the 2-1 was actually updated recently in 2024. The main intention of having this revision or iteration was to remove the duplication of whatever 2-1 actually governed in terms of building an OT IACS program. And making sure it is more unique to an OT IACS security program than overlapping with an ISMS of the 27001. So thanks, Malcolm. Really insightful. Over to you, Valerie, for the next poll.
Great, thanks for all the insights. So just launching another poll. We want to know what is the most challenging part of 62443 for your organization. So I've launched a poll. Go ahead and click. You can select more than one option. Is it understanding and interpreting the standards complexity or aligning roles and responsibilities or securing executive buy-in or integrating it with other existing frameworks? I think today Harish and Malcolm have done a really good job on sharing some of the frameworks that, there are synergies with. And of course, in interest of time, there might not be enough to talk about all kinds of other compliance frameworks, but not to worry, that's what the Q&A is for later, right? Okay, we'll give it about maybe 20 more seconds before I pass it on to Harish for a dive into a use case.
So Malcolm, what's your thought, or which one would you be choosing if you were to choose one or more on this?
I think if it was me, it would be securing the executive buy-in, because we always know, I suppose to me, control systems, SCADA, it's what we see as the black box. People don't know about it, so they tend to shy away from it. So they're more introverted. But the more that you go back out into the enterprise realm, IT is well known. Therefore, that's where the CISOs, the security manager, the board, the executive, they're fully aware of what goes on because they use IT every day of their life. So therefore, they're more focused to do that, and probably divert budget more to the enterprise realm versus to more on the control system side. So I think it's about that education process, about bringing everyone on the journey to say, okay, I do have critical infrastructure, I do have automation components within my organization that actually produces the dollars for the business. So I probably should concentrate and divert budget back that way as well. So there's got to be that, comparing apples for apples. So, how can we do that merging of the ISO 27001 and 62443? So therefore the risk appetite can be compared appropriately. So yeah, it's just about that education process.
Perfect.
Great.
Can't agree with you more.
And Harish, shall we jump into the use case?
Perfect. We wanted to keep this a bit textual and practical, balance both sides of the world. So the intention was to bring in a thought or flavor of what 62443 is and what it is not, right? So in this whole exercise, we have decided to take a practical example here. ABB being present as a leader in electrification and automation systems as a systems provider. We see a lot of our end users in this space of power and critical infrastructure sectors. So we thought of taking not a very detailed system architecture just to balance the technicality a bit, but to give you a holistic overview on top of an ABB cybersecurity reference architecture where two systems can interact. So on the left side, we are looking at the distributed control system. This is not an architecture to scale, but just an idea or an overview of how 62443 can be deployed or looked at in an ecosystem like this, right? So on the left side, we look at the distributed control system, and the right side, we consider this to be the substation automation system. In a general plant scenario, we are looking at the DCS and the substation automation system exchanging data on a real-time basis to keep the process and power aligned, right? So from the process side, the DCS sends variable load request to the substation, and from the power management system side, the substation automation system sends feedback of critical information like breaker positions, transformer loads, so that the DCS can safely adjust operations. So how does this interaction actually bring in an element of cybersecurity risk? So we are talking about bidirectional connectivity on a real-time basis between two critical process control systems, and a substation automation system, which manages pretty much your adverse situations like load shedding and ramping down equipment, power overload situations. We are talking about protocol level vulnerabilities. We are having 61850 in the ecosystem as the most crucial protocol to be used here. 61850, as most of us know, was designed for fast millisecond level response for fault detection and trip signals, right? It was not built with security in mind at the very beginning. We are talking about trust boundary exposure, where lateral movement of a threat actor is evident if we do not have proper segmentation in place. So, long story short, we are talking about how this interaction is crucial, how it could be critical in terms of bringing your whole critical infrastructure down when there is an adversary at stake, right? So when you're looking at getting started with 62443 as such, how do you do that? So we get accustomed to the terminologies, of course. Then comes the 2-1, right, which is pretty much seen as the starting point. It is basically the guide to asset owners to establish the IACS security program. But in a lot of cases, this getting started flowchart is misinterpreted in a way that I need to get my 2-1 or my program right before I start looking at my assessment or bringing in my controls. That might put you back a bit. The reason is you will not have a wholesome program until you assess what is at stake, until you know what is in your ecosystem, right? So that is where I think 3-2 brings in a flavor of everything around the assessment and gives you the freedom to establish your boundary of the system first, which is called as the system under consideration. Once you have the system under consideration established, the very first activity which is recommended to do before the assessment is understand your assets, right? Understand what is that ecosystem you have in place, understand how these systems interact with each other before we go into controls deployment. So it is not necessary to go into 3-3 and start deploying your countermeasures without knowing what is your risk profile at stake. So that is where the aspect of zones and conduiting comes into picture. So zones, as defined by IEC 62443, are logical or physical groupings of assets based on how they share similar security requirements. So in this case, we are talking about the controllers of the DCS and the controllers of the substation automation system having different security profiles, and eventually you will see that they have different risk profiles as well, right? So then conduits are basically how these zones interact among each other and beyond the perimeter, right? So this is basically how you define or identify what are your secure communication paths. Have I deployed the right level of segmentation or restricted data flow mechanisms when it comes to this? So in long story short, between 3-2 and 3-3, 3-2 helps you to find out what is your current risk posture, what is your current security target level you want to define as per your enterprise risk management policy or tolerance. And when it comes to 3-3, it is more about how you deploy the controls or countermeasures at stake, right? So 3-3 actually defines 7 foundational requirements. Malcolm is going to talk a bit on that in detail later, on how these 7 foundational requirements are actually addressed by the 62443 by Nozomi, and as part of this, we are then talking about the security levels, which is defined in 3-3, right? So we have security level 1 to 4, which is basically about how much protection is needed based on your risk level. So when it comes to countermeasures, you look at the risk, what is the mitigated risk and what is the inherent risk, and then build on your countermeasures according to the 62443 3-3 accordingly. So we have tried to address a few countermeasures here as part of this use case exercise, but for want of time, we might not be able to go through all the 7 FRs. So when it comes to timely response to events, that is where the continuous threat detection aspect or anomaly detection kicks in, where Nozomi supports our whole ecosystem, right? Malcolm, do you want to touch a bit briefly on this, on how Nozomi actually helps to address this part?
Yeah, sure. So I was thinking about a scenario in this case. So like we're implementing Nozomi to a location that operates on a flat network. So we'll have a brownfield site. So what we'll do is provide that visibility into the OT network to discover the assets and map the data flows between the assets to understand who is talking to who and how with what communication protocols. And why that's important is that information is required when designing a network around those zones and conduits, as this is what you'll need to do when you start defining that network segmentation. So just where we are and what switches we're tapped into for those spam, that's how we'll aggregate that information and start to help define those data flows.
Right. Thanks, Malcolm. So the ABB event monitoring, along with our event collector forwarder and the SIEM, along with Nozomi Guardian, ensures that the OT incident response can happen more seamlessly, and we can respond more quickly and efficiently to abnormal events in the OT space, right? So the next foundational requirement we are looking at is resource availability, where robust backup management system or a policy and disaster recovery mechanisms come into place. System hardening malware protection updates can be visually monitored, managed, and reported on the cybersecurity workplace. The next is one of my favorite foundational requirements around restricted data flow, right? So when it comes to segmentation, you can either look at it from the perspective of physical segmentation, logical segmentation, or let's say a system is isolated. Do you really need segmentation in that case, right? So do you deploy physical segmentation in all cases? Probably not. But depending on the risk profile, depending on the criticality of the assets, we are talking between zones. I think that is how 62443 structures this in a very nice and efficient way, where you define the restricted data flow or any of these controls for that matter based on the risk profile of the interacting systems, right? So here we are talking about the perimeter firewalls between the DMZ, OT, and also between IT and DMZ. We are talking about industrial firewalls between my two control systems here, and also the ABB and RP routers between my level 1 and level 2 traffic. So when it comes to identification and authentication control, we have kept it simple with the domain controller here. But if you see that you need to achieve a higher security level, you might have to look for additional solutions or countermeasures to actually match that security level. This is probably the base. Whether you build on top of this or not is depending on the risk profile of the ecosystem. The next most important part is around how you maintain and ensure your foundational security is managed with the 2-3 and 2-4. That is where cybersecurity workplace kind of builds into this whole ecosystem to support this. And the next part is where OEMs like ABB are more involved, right? Ensuring that asset owners get the secure by design aspect sorted with secure product development life cycles and component level security assurance on the 4-1 and 4-2 respectively. So certified products provide a baseline, but ABB also ensures that they are integrated securely into this ecosystem along with Nozomi in place. So this is how we have broken down the whole system architecture or the high level system architecture on how we go about this. So from the key reflections we see about what we have interacted with the OT ecosystem or asset owners so far, right? We find that 62443 should be seen as a recurring activity. It is not a one-time certification, right? OT environments are dynamic. They keep changing with digital adoption today. So it is important to ensure that they're continuously evaluated, assessed, just like how we look at process safety management, right? It is also role-based, which is the great part. The asset owners, service providers, and OEMs have their own distinct responsibilities so that security can become a shared effort, right? The other important point or misconception we see is the security level target assignment. This is not a technical score. This is more at looking at your enterprise risk management and aligning the protection requirements accordingly, right? Three common myths I will run through quickly is how complex it is to start with. So 62443 can look overwhelming at times with all the controls, the sections, and practices which are recommended. But it is important to know what you have already in terms of your assets. It is important to start small, establish governance, and ensure that it is a continuous activity. Prioritize protection of your critical assets, and most importantly, engage your suppliers, integrators, and your cybersecurity partners at the very early stages so that your program can also be wholesome, right? The other part is 62443 was built or came into prominence because of critical infrastructure, but it can apply to transport, food and beverage, water, wastewater, where it is not a critical infrastructure in a lot of countries. It is about proportional security and not the size, right? The last point is more on how certified components are perceived to give instant compliance to 62443. Just having certified products is not enough, but compliance also depends on how these components are integrated, configured, and maintained within the ecosystem, right? So I will quickly dive into how ABB and Nozomi actually help to achieve 62443 compliance in your whole ecosystem. So ABB projects the whole cybersecurity services, controls, and countermeasures on a risk reduction roadmap. So our approach is usually segmented into the OT security consulting, core security, and also the enterprise security, OT security phase, where Nozomi is our partner and work complements with our existing solutions. So OT security consulting is basically where we help to comply to the 62443 in terms of directly addressing your 3-2 risk assessment and security program establishment requirements. In the OT core security aspect, we are looking at how the cybersecurity workplace helps you to achieve your foundational security KPI visibility. And this complements very seamlessly to the 3-3 requirements as we would have seen in the use case, right? The reference architecture is basically ABB's guideline on how you architect a cybersecure system and how you can actually look at the zones and conduiting and the perspectives of multiple system interaction like we saw in the use case, right? Then comes the interesting part around enterprise OT security, where Nozomi helps us to improve our threat detection, asset visibility, and vulnerability management capabilities, which works in tandem with our event monitoring solution. This is more towards helping our end users seamlessly manage the manage, detect, respond requirements around OT threat management and incident response. So I'm going to hand it over to Malcolm to talk a bit more on the Nozomi Networks platform and how it helps to comply to 62443. Over to you, Malcolm.
Thank you, Harish. So I thought before I launch into the next slide around the 7 FRs, I thought I'd just give you some context around how Nozomi helps supports that 62443 implementation and just explain a bit of the platform architecture. So the Guardian sensors analyze and visualize data from your network to provide asset inventory and network visibility for OT, IoT, and IT environments. So they detect the cyber and operational threats and vulnerabilities to provide that situational awareness. Guardian Air provides visibility of the wireless communication spectrum. Nozomi Arc is the first host-based security agent designed to protect OT and IoT environments, which traditional IT agents can't. It also turns any endpoint into a lightweight network sensor by discovering and tracking behavior of nearby devices on the host subnet. The Central Management Console provides you with a single view of all your sensors deployed, consolidating that network visibility and risk management. Vantage is our SaaS-based solution that scales security monitoring and visibility for all your assets. And Vantage IQ Assistant is an AI-based query engine, which I think in my mind is pretty cool because it enables security and operational teams to quickly gain deeper insights into what's happening in their environment and how to prioritize issues. Next slide, please. So 62443 Part 2-1 is about running an OT cybersecurity management system. Nozomi is the visibility and evidence layer that makes those processes real. Auto-discover devices and assets with make, model, firmware, and protocols, group assets into zones, and map conduits so our design matches reality. Flag anything that bridges zones or talks outside the allow list. Baseline normal traffic and device behaviors that alert on deviations for new devices, firmware changes, or policy violations. Prioritize with risk scores that combine exposure, criticality, vulnerabilities, and unsafe communications. And IR teams are well equipped as detection service quickly with context. They can do that one click for capturing the PCAP for forensics, and then forward those alerts onto the SOC via syslog or to a SIEM. If an unknown device appears or a session breaks policy, push an API action to the NAC or to a firewall to quarantine or block. Audit trails for access, alerts, and response steps, which are artifacts for 2-1 audits and or for board reports. And then moving on to 62443, Part 3-3, those 7 foundational requirements are what outlines the system security requirements and security levels for a product. So if I start with FR1, the identification authentication control. Vantage supports built-in 2-factor authentication for user accounts. Guardian CMC supports SAML, AD, LDAP, so you can enforce your MFA at your identity provider, and also single sign-on for our sensors. Use control. Assign minimal roles and Vantage, CMC, Guardian for least privileged access, and set idle timeout for session management. System integrity. So Guardian built-in checks and learn baseline alerts, identify protocol level issues, new or changed nodes, and other relevant anomalies. For patch and vulnerability handling, software updates are centrally orchestrated, and also Nozomi maintains the PISO with advisory and fixes. Health logs track the CPU, RAM, disk load, and sensor issues for integrity and availability oversight. So FR4, data confidentiality. Nozomi encrypts data in transit and at rest and Vantage, and the platform architecture uses secure protocols to sync data. Restricted data flow for FR5. Define zone configurations in CMC or Vantage and propagate to sensors to reflect the intended data pathways. Guardian's firewall integration can auto-create block policies and enforce restricted flows at the firewall. And also, ARC can block malware upon detection on the endpoints. The timely response to events for FR6. Guardian collects alerts, health, and audit events and forwards them to the SIM or SOC. Use our alert playbooks in Vantage CMC to standardize the operator steps and integrate with the SOAR for automated actions. On FR7 for resource availability, CMC high availability replicates data between paired consoles. Schedule those backup and restore on your Guardian and CMC to protect the configs and operational data. Sensors are passive only to avoid impacting that OT traffic. So Nozomi is that visibility and response layer that operationalizes 62443. Paired with that IDP, your firewalls and SOC, it enforces the least privilege, restricts the data flow, detects unsafe changes, and produces exportable evidence. So embed that within your 27001 and your 62443 2-1 program, and you can turn these 7 FRs into daily practice across your OT environments. Thank you, and over to you, Valerie.
Thanks, Malcolm. Thanks, Harish. So just to get a quick understanding before we jump into the Q&A, are you currently using Nozomi Networks and or ABB cybersecurity solutions to support your IEC 62443 implementation? So go ahead, answer that. And into the chat box, I've actually shared quite a couple of resources. So once you're done sharing with that, you can either explore the resources or you can start to type your questions into the Q&A box. We've already are seeing more than 10 questions, so we're going to do our best to answer them today. So next slide, please. Taking you guys through a IEC 62443 content pack that we have on our webpage. It's well equipped to bring everyone together with a set of reports and queries that will help you access the details needed to assist in compliance efforts. So rather than reinventing the wheel each time a customer needs this data, we can create a single file, we distribute it, and then this can be imported into our Guardian. So I think we can skip to the next 2 slides where we have our Gartner Voice of the Customer report. Yeah, so I'm also very, very proud and excited to share that Nozomi Networks is the only vendor recognized as a 2025 customer choice in the Gartner Voice of the Customer for CPS platforms. Of course, we have this report available for you. I have popped this into the chat box as well, and feel free to grab your complimentary copy. And with that, I shall not delay us from the Q&A. Harish and Malcolm, please.
Yeah, I think a fair bit of questions here. So we might have to choose between them for the want of time, but I'm sure Valerie is going to send out the responses for all in probably a nice documented format so that we don't miss out any of these nice questions, right? So I see that we have one which talks about 4-2. Is 4-2 applicable only for components, or can they be applicable for systems like DCS? This is also something we hear a lot from our customers. So I'm going to try to address this. So let's take the ABB control system into play. We are talking about the 800XA or the Symphony Plus, right? So 4-2 actually looked at embedded device security assurance, which is more of the way you certify the component level security aspects, right? This was eventually turned into component security assurance, or CSA, as part of the 4-2. So as OEMs or product suppliers, there is a portal on ISA Secure where you can go and see whether an ABB or another control system is certified under this or not, right? Having said that, this differs from how you can, this only looks at component level or controller level or device level. When it comes to the system level, like a DCS system on the whole, that is where 3-3 actually comes into picture. So that is how 3-3 and 4-2 actually are distinct, and also in a way complement to the overall security, the 62443 compliance of the whole system under consideration. So Malcolm, I think there is one on the difference between ISMS and CMS. Is ISMS an overarching umbrella under which CMS is built? You want to take that one?
Yeah, well, I suppose the ISMS is more around the information security management system. That's for the organization more wide governance around that information risk, the policies, that risk treatment, suitability of application, audits, continual improvement. Whereas the cybersecurity management system for industrial automation control systems, or the CSMS, that's what it is. It's based around the OT industrial program. So scope, I suppose ISMS is more around the information assets, could be the IT systems, cloud, data, people, and processes. Whereas the CSMS, it's more, what are we looking at in the industrial control system for the PLCs, RTUs, HMIs, engineering workstations, the safety instrumentation systems, the control networks, the OEMs that are working in there, etc., the system integrators. So, and then looking at from an ISMS perspective, what's their primary objective? It's that confidentiality, integrity, and availability, and business continuity. Whereas the CSMS is more around that safety and availability first, and then the integrity and confidentiality. So we're looking at it from a different perspective, and also the controls as well. ISMS will look at ISO 27002 for the controls for that statement of applicability and how do we measure the effectiveness. Whereas the CSMS will, we define the zones and conduits within part 3-2. We set those security level targets, and then we implement those FRs, the 7 FRs, 1 through to 7, around the system requirements. So there's quite a bit of difference. ISMS is more information bound versus the CSMS is more, we're looking at a system as a whole.
Right. Thanks, Malcolm. So there is another one on, is there a link between 62443 and the Singapore CCOP? Just to give a bit of background, the CCOP was built or drafted by the Cybersecurity Agency of Singapore, mainly to address the cybersecurity requirements or guidelines for the Singapore critical infrastructure, right? 62443 is more of a generic one, which addresses OT IACS systems on the whole. It is a global standard, right? So having said that, our CCOP and 62443 very different. There are overlaps between each other. If we look at the OT master plan of the CCOP, which of the CSA, which was launched or drafted in 2024, we see some glaring overlaps on the strategies or recommendations like secure by design, secure by deployment, which is also being advocated by 62443, but on a different structural level, right? So in short, CCOP is more for regulatory compliance for CIAs mandatorily in Singapore. 62443 is where you can take the whole OT security maturity journey across from 2-1 all the way through your 3-2 and 3-3 and keep building and improving it as a global standard or reference, right? So that is where it both works. So Malcolm, you want to choose one? There are a lot, but there are lots.
How about monitoring site with unmanaged switch? So there's no port mirroring or span port. So I come across this all the time. I've been doing the Nozomi deployments for nearly 7 years, and where there's the old legacy sites, so they don't have managed switches. So there's probably 2 options. You could deploy network taps. So it doesn't matter if it's a managed or unmanaged switch then, and also you're showing that you're not going to put any more compute resource overhead onto that switch, even if it was a managed switch. So you just tap into that actual patch cable, being fiber or copper, it doesn't matter. And then the other option that you have could be deploying the Nozomi Arc endpoint agent. So as I was just going through earlier, so that can be deployed on one of your engineering workstations, being Linux, Mac, or it could be Microsoft operating system, and it acts as that sensor and then can tell you what's going on in and around that network as well. So again, if it's unmanaged switch, I've got a tool in my toolbox that I can pull out and do. So it could be a network tap or it could be an ARC endpoint.
Right. Thanks, Malcolm. So I'm quickly going to take this one. In slide 15 or the use case slide, I think we had many firewalls which are actually used in the system. I'm concerned about the cost and maintenance. The reason why I'm taking this one is also a very common concern among the asset owners or the end users, right? How do we actually balance the security cost versus the risk element? So to answer this question is exactly where 62443 comes into picture, right? So what we have shown here as a blueprint is the most ideal way or a reference to do it, right? But it is not the most correct way always to do it. Why? Because I am looking at the risk of two quite critical systems here, and then it makes sense for me to actually physically segment them depending on the criticality of the systems and the communication and the data flow between them or between the zones, right? So that is exactly why it is not recommended to follow a blind guideline around security countermeasure deployment, but rather to look at your enterprise level risk tolerance and appetite. Look at your risk assessment, what is your inherent and mitigated risk, and then look at your countermeasures appropriately. There could be cases where the PMS system is isolated with just one connection going out to the low dispatch center. There could be a different case where there are other controls in place which you do not see in this architecture today, right? So that is why 3-2 is going to give you that picture before you actually take a call on whether you need this huge chunk of firewalls into your system, or probably you could logically segment it in certain cases, or probably eliminate even having the firewalls in certain cases, right? So always look at your risk and then build your countermeasures appropriately. But great question and concern. Any question you want to take, Malcolm?
Oh, I'm just looking through them all. I think there's a quick one here around the AMR network to be located. Where should that be? So I think in my experience, that's probably not trusted network, sitting out in the field. So that should probably come through its own leg off the firewall in the DMZ. So to me, that's where it should be coming in and have its own little server sitting in there, because it's not purely coming from your trusted SCADA network. It's coming from the field area network.
Right. So there is one question on what might happen if the firewall at level 1 fails and block the communication among the zones. Great question. I think on the use case, we have not depicted redundancy or high availability, just to keep it more generic. So from that perspective, whenever there are conduits being looked at, and if there is a communication path or a secure communication path between two really secure zones, it is also important to look at this point, which has been highlighted by the attendee in this question, on what if there is a failure of this communication path, how does it affect my operational availability? 62443 always looks at your risk from operational, financial, reputation, and few other factors of consequence, right? Operational being more critical in this case because we are talking about the system being unavailable or the communication being unavailable. So in this case, it is always important to analyze the criticality of the communication at stake and then evaluate if there can be redundant communication paths which are also equally secure by whatever additional controls we can bring into place, probably a redundant firewall, probably a different configuration of it to ensure that my redundant control network and client server network are always available through these RNRP routers or the firewalls, right? Great question. Thanks. Malcolm, anything you want to take? Valerie, I think we are a little over time.
I'll probably last one. There's a question that's just popped up. How does Nozomi help prioritizing vulnerabilities in OT? It's difficult to deal with the high number of vulnerabilities based on the CVSS score. So what we have in there is also the known exploitable vulnerability flag. So that we've used that to dilute, I suppose, and you're looking, some customers will have might be 10,000 vulnerabilities for sake. When you turn on the KEB flag, it actually brings it down to within the hundreds, if not less, because there's not every vulnerability is going to be exploitable. So understanding that enables you to then prioritize what to be looking at. And then there's also the other one that we have is the EPSS score, which again looks at what that predictive scoring is around the vulnerabilities. So it's another weighting that you can apply to verify against the known exploitable vulnerabilities versus those exploit the EPSS scoring.
Yeah, so there is one on, we have our own company framework in place for our OT networks, mostly compliant to 62443. But still, if wants to confirm compliance to latest IEC requirements, from where can one start to see any gaps? So the reason why this question is coming up is also because of the fact that 62443 is evolving continuously, right? We are seeing revisions and iterations of the 2-1. We are seeing the security profiles now coming into picture with the 5-1, and which is going to complement to the 1-5, which is already in place. So there is a constant effort to make 62443 more relevant, more applicable to organizations, right? But the reason why this question is very apt is a lot of organizations and enterprises have their own enterprise OT security policy. This was not built as a cut copy paste of the 62443 primarily, right? It was probably derived with their own priorities and mechanisms, which also were brought into that governance element. So from that perspective, if you want to look at compliance to 62443 or what has changed or what has new, and if you also want that to be a tool or a feedback to improve your organization's OT security policy, ensure that you have a good quality assessment done against the 3-2, and also evaluate your 2-1 as part of this whole assessment process to see what are the gaps. So there are two elements of assessments which can go in. On the system level, we are talking mostly on the 3-2, right? And then there is also a cybersecurity maturity assessment, which can actually be done to ensure that we are not only looking at technology, but we are also looking at the policies and people and processes in place, right? So that is probably a good start to reevaluate your 62443 compliance or where your OT security policy stands today. For all the other questions, I think really great questions. Tempted to answer them, but I'm definitely going to sit back and draft out answers to you, all these, Valerie. I think these need to be addressed.
Yes.
Thanks for all the questions. Apologies for not being able to answer all. Yeah.
Yes, thank you so much, Harish, and thank you so much, Malcolm, for your time. And thank you, everyone, for joining in today's session. I'm just going to stay online for about 2 to 3 more minutes for those of you who want to put in your emails into the chat box with your questions. And then the rest of us, Harish, Malcolm, happy to return you your time.
Thank you so much for the opportunity. It was great collaborating with Nozomi on this. Thanks, Valerie. Thanks, Malcolm.
That's been a pleasure. Thank you for your time as well.
Thank you so much, everyone. Bye-bye.